Find the circumference of the circle. Label points B, C, D, and E. Join line CD and line DE. Let angle CBD equals θ, which equals angle DB of E. From triangle CBD, use cosine rule. The square of line CD equals the sum of the square of line BC and the square of line BD minus 2 times the product of line BC and line BD times cosine θ. Substitute values and we have that the square of line CD equals the result shown on the screen. Simplify this result and we have that the square of line CD equals 173 minus the product of 52 and cosine θ. We call it equation 1. Locate the center O of the circle. Join line OC and line OD, each equals to the radius R of the circle. It implies that angle COD equals 2 times θ, which equals to 2 times angle CBD. From triangle COD, use cosine rule. The square of line CD equals 2 times the product of the square of R and 1 minus cosine 2 times θ. By trigonometric identity, cosine 2 times θ equals 2 times the square of cosine θ minus 1. It implies that the square of line CD equals 2 times the product of the square of R and 1 minus 2 times the square of cosine θ plus 1, which equals to 4 times the square of R and 1 minus the square of cosine θ. We call it equation 2. Consider triangle DBE and use cosine rule. The square of line DE equals the sum of the square of line BE and the square of line BD minus 2 times the product line BE and line BD times cosine beta. Substitute values. The square of line DE equals the sum of the square of 11 and the square of 13 minus 2 times the product of 11 and 13 times cosine θ. It implies that the square of line DE equals 290 minus 286 times cosine θ. We call it equation 3. Join line OE and line OD, each equals the radius R of the circle. It follows that angle DOE equals 2 times angle DBE equals 2 times θ. This is because angle at center is twice that at the circumference of the circle. From triangle DOE, use cosine rule. The square of line D equals 2 times the product of the square of R and 1 minus cosine 2 times θ. By trigonometric identity, 1 minus cosine 2 times θ equals 2 times the square of cosine θ minus 1. It follows that the square of line D equals 4 times the product of the square of R and 1 minus the square of cosine θ. After simplification of values, we call it equation 4. Equate equation 1 and equation 2. We obtained a new equation as shown on the screen. We call it equation X. Equate equation 3 and equation 4. We have that 290 minus 286 times cosine θ equals 4 times the product of the square of R and 1 minus the square of cosine θ. We call it equation Y. Finally, equate equation X and equation Y as shown and combine like terms. We have that Negative 52 times cosine theta plus 286 times cosine theta equals 290 minus 173. (234 times cosine theta equals 117. Divide the equation by 234 and we have that. Cosine theta equals 117 divided by 234 equals half. Substitute into equation 1. It implies that the square of line CD equals 173 minus half of 52, which equals to 147. Substitute value of the square of line CD and cosine theta into equation 2. (147) equals 4 times the product of the square of r and 1 minus the square of half, which equals to 3 times the square of r. Divide the equation by 3 and we have that. The square of r equals 147 divided by 3, which equals 49. Take the square root of the equation. R equals the square root of 49, which equals 7 units. Hence, the circumference of the circle equals 2 times the product of pi and r, which equals 44 units. After simplification of substituted values. Therefore, the circumference of the circle equals 44 units.